whenever you'd like. Just explain
Okay.
what you got.
So before we go anywhere, I'm going to explain some of the actual physical motor stuff. So right now, the first circuit that we have on the bottom over here, the bottom breadboard, is a motor circuit. So basically, we have 4 PWM signals that come down into the motor circuit down there, where they all go into opto isolators to protect the microcontroller, and then I'll go through an H bridge directly through to the motors themselves. We have a couple other circuitry items like a 5-volt regulator, and a whole bunch of other electrical components in order to make sure that we have the correct power and voltage ratings throughout the circuit.
Cool.
And then the second level, we tested the sensors first with a function generator before like connecting it to the PWM signals, and we realized that the readings that they provide are very, very low. So if we were to connect them straight to the ADC, like they would not give anything basically. So the second level goes through first an amplifying circuit that gets rid of noise because there are some diodes, and also amplifies the signal. And then goes into a high pass filter because the circuit doesn't just amplify but also give it like a DC offset, which is not something that we wanted, so we just like ran it through a filter. And then it goes to through a full wave bridge rectifying circuit with some capacitors just to make sure that the signal doesn't like decrease too fast.
Reduces ripple?
Yeah.
Okay.
And then after that, we did get a DC signal, but it still wasn't high enough, so we ran it through another set of amplifiers that are just like non-reverting,
Okay.
like op amps.
And the sensors that these interface with are here, correct?
Yeah.
So these are ultrasonic sensors?
Yeah, so the input or like the output of these goes into like this entire circuitry.
Sure.
And then the value after like it comes through all of that goes into the ADC.
So these sensors are producing a low magnitude oscillating signal.
These are receiving.
These are okay,
Yeah.
okay. So
yeah, so the first amplifier circuit, I found that from a paper that's specifically for this application. So it's like an ultrasonic transducer amplifying circuit.
Cool. Wow, that's a lot of work to get those signals into the
Yeah, so this stick is what like produces the sound waves, and then these receive them, and then those values that they read go into the ADC, and then the robot like moves depending on what the values are.
So there's another PIC32 here driving. On the other side, there's 2 others of these, correct?
Right.
Yeah, so this circuit, we also try to amplify this signal, but then we failed. We tried like all different ways. But
Sure.
Yep.
So we just like ended up straight connecting like these sensors to the PWM signals.
Gotcha. Okay.
Yep. So, and then finally, the ADC values that get fed into the PIC32 at the top will get somewhat pre-processed before it actually does some calculations with the measurements. And in the software, we determined that the threshold for the left and right sensors activations are different, so we had to calibrate for those. And also, because these are very sensitive sensors, we implemented a logic that would first like take a couple of thousand diastolic cycles just to calibrate with the ambient environment, and for later ADC readings, we subtracted off of the ambient reading such that it will normalize to certain levels.
Gotcha.
Yep.
So there's sort of a calibration phase at the beginning.
Right.
and
Right.
then- okay.
So in the later demo, you'll see that the LED light would turn on when the calibrations are done, and that's when we are going to be able to like securely use this stick to guide the robot.
Okay.
Yeah, I think the signal received by the left and the right just ended up being so uneven because of the sensors themselves. Like we tested them, the oscilloscope, and the readings are like a little off.
Okay.
So we first tried to fix it with the hardware, just like changing different capacitors and like different like gain values, but it was very difficult, and also it really depends on like the orientation of the stick.
Mhm.
Like sometimes the left one is more sensitive, and then other times they're like almost the same. So yeah, we had to do a lot of things in software just to try to calibrate them too.
Right. And also we use like different measurements such as like raw ADC readings and normalized measurement ADC readings and also just the voltage values themselves. So those three combined created a logic that would like concretely determine the direction of the motor as possible. Yeah.
Gotcha.
Yep.
There were a lot of ideas that went in to try to make the sensors better, but in the end, they're just not good sensors.
So are you going off the amplitude output of the sensors?
Yeah, so
Times
we have like the wave, but then we rectify that and then like.
Okay,
through
so,
that.
but what you're separate, when you say you're detecting the sensors, you mean the amplitude of the output,
Yes.
as opposed to time of arrival?
Yeah, it's
Because the closer you get with these sensors, the larger the amplitude. So.
Cool.
And also, just in general, as a general overview, we call this the cat robot, aka his name is Karen, because it doesn't do what it wants us to do like most of the time. It does have some undefined cat behavior. It does whatever it wants, but it works generally. The idea is pretty cool, and then I guess we can do the physical demo now.
Okay.
I think so. You probably want to bring it over.
Maybe over here on the floor.
Yeah. So there are two switches, and what you can see. Actually, let me turn this off first, so then I can. So as you can see, turn it on. There's a cat face. Okay. Okay.
Yeah, so the calibration's done. So if we can make it go straight, make it turn left. Yeah, it did the calculation. There you go. You turn it right.
So you're guiding it with the other two sensors.
Yes.
So it's sort of basically like a laser pointer or like a cat toy that you wave in front of a cat.
Yeah, it reminds me too of like dragging a string in front of a cat or
Yeah.
something, and so it's a similar kind of effect.
Yeah. So you can define cat behavior just every once in a while. So it's a little hard to control, but it gets the job done.
And so are cats.
Yeah.
And I'm noticing too that the cat looks in the direction that it's turning.
Yes.
So right now it's looking left.
Yeah.
I can't accumulate too much to go to the left. Yeah.
Yeah, there was another thing. Originally, we didn't want the sensors to touch, but then we realized that the distance at which they actually read anything is so small that it's just like physically hard to control it.
So it's easier to just touch them.
Yeah.
Yeah. And I guess some circuitry items that the reason when you touch it, basically it gives us its highest reading basically. And because Professor Lam was telling us the other day that probably the reason why it does this is because we have a high pass filter that has a large tau value that accumulates a lot of that takes a long time to basically drop the voltage to a specific level that we want.
Okay.
But by that point, it was a little too late to change it. So.
Yeah, we tried to clear out the capacitor values just so the readings like drop a little faster, but then they become unstable at one point. So if the capacitors are too low, then the values just oscillate and it doesn't do anything.
Did you guys want to try?
I'll try one, yeah.
It's a really hard to control, but yeah.
Well, it has a lot of personality.
Yeah.
Yep.
It's definitely Karen though.
Oh my god.
But straight is a little bit better than the other. Just because it's for some reason it's actually able to detect it at a distance, but
Okay.
But yeah, left and right are definitely a little bit harder sometimes.
Awesome.
Mhm.